Hello friends, so today we can discuss the problem A and B from the latest AtCoder regular contest 109 problem. The first problem is hands, so let's discuss this. There are 200-story buildings called A and B. So always try to draw the question because it will become easy for you to understand the problem statement. So there are 100 buildings, 100 floors. I'll just drawing out 4 floors, numbering out 1, 2, 3, 4 and same 1, 2, 3 and 4. Okay, so now as you can see, for each 1 till 100, the ith floor of A and the bth and the B are connected by a corridor. Okay, so every the same floor are connected by a corridor, so these are corridors. Okay, and also for each of the 1 till 99, there's a corridor that connects the ith plus 1 floor of A and ith floor of B. So if there's a ith floor of B and this is the ith floor of A, so this is A and B. So these are also connected like this. So these are also corridors. So these are the corridors connecting between these two buildings. Okay. So the next thing is, okay, so you can traverse in those corridors in both the direction. These are bi-directional stairs, corridors, in which it will take X minutes to go to the other end. Okay. Additionally, in both of the buildings, there are staircases also. So like to go from the ith to the ith plus 1 floor. Okay. So it means that there are staircases also like this. If you want to go to the next floor, like this. So it will take Y minutes and it will take X minutes if you want to go from one into another. And now the question statement states to you, you have to find out the minimum time required to reach the bth floor of B from the 8th floor of A. So you are on some floor on A and you have to reach on some floor of B. Then what is the minimum time required? And these are the corridors which will take X minutes, and these are the stairs which require Y minutes. So that's the whole problem. Now let's think about different cases. The first case is because let's assume that you are on the same floor in A and B. So let's assume that you are on the second floor on A and you have to want to reach the second floor of B. So there is only one corridor and it's simple to just move around that corridor. So the answer will be this corridor time, which is X, if both of them are same. Okay, if both of them are different, let's assume that I am on A, which is equal to this, the last floor, and you want to reach on this floor, which is B on the top floor. Then you have two options. The first option is you can either go like this, go to this floor. So 1, 2, so you just go 2 floors up and then move along the one corridor. You can also do like this, which is move along this corridor and go 2 stairs up, but it's equivalent because moving along the stairs is same in both of the buildings. So you can also do like this and one move corridor. So the thing here is, in first case what you can do, you can move along the 2 staircase and then one corridor, or else what you can do, as you can see, if I am on some floor like in A, I can go to the next floor by doing one corridor and second corridor. So doing 2 corridor moves, you can go to the next floor. So you can either go to the next floor using Y stairs or by using 2x time. So or Y minutes or 2x minutes. So because let's assume that X might be very small, X might be like X equal to 1 and Y equal to 100. So it's always beneficial to take 2x time instead of Y stairs. So you have two options. You can either go 2y or you can either go like this. And in the end, let's assume that if you reach at this point, then you can just go to the corridor. So the total time is either you can take all the staircase and then one corridor, or you can take corridors 2 times X and then the last one also. If you reach the same level, then take one more corridor. So 2x into difference plus 1. So this is the thing in which you are on the lower level and B is on the higher level. Okay. Now there can also be a case in which let's assume that you are on the higher level and you are on this level and B is on a lower level. Then you also have the same case in which you first go to one corridor and go to down, which is the same. But the second case is in this, because as you know, for every going one level down, you require 2 steps. As you can see, this 1 step and 2 steps. But as you can see, because my B is lower, let's assume that if I want to reach at the second floor from the third floor, You just take one staircase down, and that's a benefit. You don't require two steps. So for corridor, if A is higher than B, then you just required one step to go down, and then you just require that, or like you can reach this point. Okay, and then if you reach this point, then you can like go to this point and then reach to this point, or you can either go to this staircase and then move like this. So in this case you have three cases. The first case is you can go to the first corridor and then go down, but because you just take one corridor and going down, instead you can take this corridor and go down, because you are decrementing your value by 1. Or else what you can do, you can take these two corridors and then go to, like, for every two corridors you can decrement your level by 1, but because this initially, if you just take one corridor, you can decrement your level by 1, but if you want to reach 1, take 2 step down and then 1. So I hope you get the point how you are solving this. You can draw it out to even make it more clear. I'll take it on to the code part now. So this is the code. I think this is the code. Yeah, this is the code. As you can see, we take the input of A, B, X and Y. So if A and B are same, so just take the corridor 1, you have to just travel the one corridor. If A is less than B, which means that A is on the lower level and B is on the higher level, then you have to find out the difference between A and B, and the answer is minimum of either take all the steps to that, the difference into Y plus X and take one corridor, or you can, because the difference you know, so difference 2 times X, so for every difference you do a 2 times X to go to the next level, and then in the end just take 1x for the corridor. Else if B is smaller than A, then find out the difference, and then you can either go in the same way in which you can go to the difference like into Y plus 1, or you can do the same thing, difference minus 1 plus X. So this is not required because this is there only. So you can do like this, you can do like this, or as I've told you, for every difference difference minus 1 times you have to do 2x, but for the last difference you have to just take one corridor down, and you have to find out the minimum among both of these cases, and the answer is just the answer. I hope you understand the first problem now. Click on the second problem. The second problem is you are given that you have to buy some logs, you have to buy n logs, and the logs like length is 1 2 3 till n. So you want to buy, let's assume that if you want to buy 5 logs, then you have to buy logs of length 1 2 3 4 and 5. So you are given n, which is the maximum length log you have to buy. So you will buy all the logs between 1 till 5, and then you like go to a shop in which the shop has n plus 1 logs in the stock. The n plus 1 logs is like the shop has logs 1 2 3 till n plus 1. So if you go to a shop, it has logs like this 1 2 3 4 5 and 6. These are the logs in the shop. Now, but what you can do, every log in the shop costs you 1 yen. Okay, so like 1 rupees or 1 yen, whatever you can say. So you can buy every log with 1 yen. But after buying one log, what you can also do, you can cut this log down. So if you cut this log down, then it is beneficial to just take that log, cut this down, and make the original logs which you want. Okay, see, if I want finally that I have all these logs of length 1 2 3 4 5, I can either buy 5 logs from the shop 1 2 3 4 5, and this task can be done. Okay, no problem, I will require 5 rupees or 5 yen. But what the alternative can be, if I buy the 6 length like wood, then I can make the 6, cut it out into 1 part, then 2 part and 3 part. So this all are completed using this. Then I just have to buy this 4 and 5. So as you can see, we just have to buy just now 3 logs, and that's the answer for this. We don't have to buy all the 5 logs, we just can do this in 3 steps. And that's you are asking this problem, how many minimum amount you have to need to like buy all of these logs from this, or you can get all of these logs from this shop. So the best way to solve this problem is you will keep on iterating from left to right and find out the maximum total you can make from the maximum length. Because see, the maximum length log can be cut in such that what is the length you can make from starting, because this is the maximum length rod. Okay, now from the start keep on adding the total length like 1 2 3 4 such that its total length is less than this. If it is less than this, then keep on adding, else if you overshoot it, you can easily know that okay, I can make all of these rods using the maximum length rod, as you can see, which I have done. The the 6 length rod can be used to make all of these rods, and then the remaining rods can be bought individually, but the maximum rod will be used to make all the smaller rods, and that's the logic for this problem. So the summation for all the n, but because this n is very large, you cannot do this in brute force way. So but you know the formula for finding out the summation for 1 till n numbers, which is n into n plus 1 divided by 2. So as you know that this is like an equivalent to n square. So which means that like this is the maximum number you want to find out, which is n plus 1. The value of this number is because the total length of this is n, and the maximum length log is n plus 1. Okay, as you can see, n plus 1. So what you can easily do here is if you know n square, if you know the value, let's assume the value in this is 10 to the power 5. Okay, so what you can do an under root of 10 to the power 5, which is like roughly equal to, or 10 to the power 6, which is actually equal to 10 to the power 3. So you can easily see that okay, if 10 to the power 3 is the maximum number, what I can do here is I can keep on adding numbers from 10 to the power 3, like, which means that I will add number from 1 plus 2 plus 3, because adding these numbers will be 10 to the power 3 into 10 to the power 3 plus 1 divided by 2, and this is like n square, which is equivalent to 10 to the power 6. I hope you get my point. So because I am finding out n, but when I put it in the formula, it is like n into n plus 1 divided by 2, it will get this point equal to this point, but this might overshoot it. So we will do this iteration 2-3 steps back. I'll tell you down in the code part now how I am doing. So that's what I'm doing, and when I find out the total length less than this total, how many logs I can accommodate or make from the longest log, the rest of the logs I can make them individually, and all of these logs can be made using only one n, and that's the logic for this problem. So what you'll do, you just do a square root of n, okay, and then you just take 2-3 steps back and then keep on adding x. Means that I'll just go 2-3 steps back, and just from 2-3 steps back I will keep on adding that. Okay, if I have, or what I will do, let's assume that my n, or the total number from the start, the total number of logs I have taken from the start is equal to, let's assume that 100. Okay, now my under root of this n comes out to be 100. So I'll start out that okay, let's assume that the total length from start I have taken equal to 98. If I have taken 98 logs from the start, what is the total sum of that? If the total sum of that is less than n, then n plus 1, then it is fine. I will go to the next step. Now I will check for 99. If still it is less than n, then okay, I'll go to the next step. Now if it overshoot n, that okay, I will know that till 99 I can make all of these logs using the n plus 1 log. Okay, so that's what I'm doing. I'm iterating from 1 to 3 steps back and finding out the summation from 1 till this x value, and if this is less than n plus 1, then keep on adding into x, else if it's overshoot, then we can know easily that x minus 1, the length will x minus 1 will be having the total length of the logs I will make from the first chain, like only one block, and then how many remaining blocks are there, n minus x plus 1. So these are the remaining number of logs which I have to make. So the total rupees I have to spend, or total yen I will spend, is I have to bought all of these logs individually, so n minus x plus 1, and plus 1 for buying out that one longest log which will be used to make all of these small logs. So that's the logic for the second problem. I hope you understand both of the problems. The link of these codes will be down in the description, and if you still have any doubts, you can ping me on my Telegram channel. I'll be very happy to answer all your queries. I'll see you in the next one. Keep coding. Bye.